Welcome to the majestic fjords of Norway, a natural masterpiece that defines the landscape but presents an immense challenge for modern transportation systems today. For decades, traveling along the western coast has meant waiting for ferries, making simple trips take hours and hindering the region's economic growth potential. The E39 coastal highway is the lifeblood of the region, yet it is currently interrupted by 7 different ferry crossings, stretching a journey to 21 hours. To solve this, Norway has launched one of the most ambitious engineering projects in human history, a $47 billion plan to conquer the deep. The vision is bold, building the world's first submerged floating tube bridges, suspended hundreds of meters below the surface to bypass the treacherous fjord waters. With a staggering price tag of $47 billion, this project isn't just about roads, it's about redefining the limits of civil engineering and technology. Engineers and scientists are working tirelessly, calculating every millimeter of the stress and pressure that these massive structures will face in the unpredictable North Sea. Every detail matters when you are building something that has never been attempted before at this scale, where failure is simply not an option for anyone. This kitsch bond involves sinking massive structures into depths that would crush ordinary pipes, requiring specialized materials and revolutionary construction techniques developed over several years. Once completed, this network will connect cities like never before, turning a grueling day-long trip into a seamless drive through some of the world's most beautiful scenery. But before the first car can drive through, the team must overcome nature's most formidable barriers, starting with the incredible depth of the Norwegian fjords. Some of these fjords are over 1,300 meters deep, so vast that the world's tallest skyscrapers could easily be hidden beneath the waves without a trace. At these depths, traditional bridge pillars are impossible to build, as no foundation could reach the bottom while remaining stable against the crushing ocean currents. The sheer weight of a pillar reaching 1 kilometer down would cause it to collapse under its own gravity before even supporting the road above it. Above the water, the weather is just as hostile, with gale-force winds and massive waves that would make a standard suspension bridge vibrate and eventually fail. The intense North Atlantic storms bring winds so powerful they can twist steel, making traditional aerial structures a risky and high-maintenance choice for this region. Aerodynamic forces in these narrow valleys create a wind tunnel effect, increasing the speed and turbulence of air hitting any structure built above the water line. The solution was to go where the weather cannot reach, deep into the water where the environment is stable and shielded from the surface storms. The E39 project spans over 1,100 kilometers, aiming to eliminate all ferry dependencies and cut travel time by more than half for every traveler. This massive overhaul will transform the west coast of Norway into a single connected economic zone, boosting trade and tourism across the entire northern region. Imagine reducing a 21-hour marathon into a manageable 10-hour drive, all thanks to the power of advanced engineering and a daring new vision. To achieve this, the Norwegian Public Roads Administration is pioneering the Submerged Floating Tube Bridge, or SAFTB, a concept never before built in history. These aren't just tunnels, they are giant concrete vessels anchored in place, floating at a precise depth to allow ships to pass safely over them. By remaining underwater, the tunnel is protected from wind, ice, and waves, providing a safe and consistent environment for drivers regardless of the weather. The structure must withstand immense external pressure while remaining flexible enough to handle the natural movements of the sea and the weight of traffic. Inside, the experience for drivers will be similar to any modern highway, with advanced lighting and ventilation systems ensuring a comfortable and safe journey. Depending on the location, these tunnels are either supported by floating pontoons on the surface or anchored directly to the seabed with high-tension steel cables. This hybrid approach allows the design to adapt to the specific depth and width of each fjord, ensuring maximum stability for the entire highway network. Safety is paramount, so the design utilizes 2 separate tubes, connected by emergency passageways, allowing for easy evacuation and maintenance without stopping the traffic. The cables anchoring the tubes are made of high-strength steel, designed to last for over a century in the corrosive saltwater environment of the ocean. At its heart, the SFTB relies on Archimedes' principle. The tunnel is naturally buoyant, meaning it wants to float up towards the surface of the water. By carefully weighting the structure and using powerful anchors, engineers create a perfect state of equilibrium, keeping the tunnel locked at 30 meters deep. 30 meters is the magic number. It is deep enough for even the largest cruise ships and oil tankers to pass over without any risk of collision. This ensures that Norway's vital maritime traffic is completely unaffected by the new highway, preserving the traditional use of the fjords for shipping and fishing. Each section of the tube is a masterpiece of materials science, utilizing high-performance concrete that can resist the extreme pressure and salt of the deep. Advanced coatings are applied to prevent any water ingress, ensuring the interior remains dry and safe for the thousands of cars that will pass through. Thousands of sensors will monitor the tunnel's health in real time, detecting any movement, stress, or leaks instantly to allow for immediate corrective action. Unlike a rigid bridge, the SFTB is designed to be slightly flexible, allowing it to absorb energy from currents and small seismic events without cracking. But these currents are not to be underestimated. The North Sea is known for its powerful underwater rivers that can exert massive force on any structure. Engineers must calculate the vortex-induced vibration, a phenomenon where the current could cause the tunnel to shake violently like a guitar string. To prevent this, the exterior of the tubes is shaped with the specialized fins that disrupt the water flow, keeping the structure stable and quiet underwater. Large flexible joints are placed every few hundred meters, allowing the long structure to breathe and move with the changing temperature and water pressure. Safety systems are redundant, with fire suppression technology and isolated emergency shelters that can protect people for hours in the event of an accident. A dedicated control center will watch over the entire E39 network 24 hours a day, using artificial intelligence to manage traffic and respond to incidents. Massive ventilation shafts, some hidden inside the floating pontoons, will ensure that air quality remains high and exhaust fumes are quickly removed. The design incorporates advanced fire-resistant materials capable of withstanding extreme heat, preventing structural damage even in the worst-case vehicle fire scenarios. The challenge is immense, but the Norwegian spirit of innovation is fueled by a history of conquering the sea, from Vikings to modern oil rigs. Norway has spent decades building some of the world's largest offshore platforms, giving them the unique expertise needed to anchor structures in deep water. However, the seabed of a fjord is often covered in a thick layer of soft mud and silt, which is a nightmare for anchoring heavy structures. This unstable ground requires a revolutionary approach to foundation engineering, one that was famously tested during the construction of Japan's Kansai Airport. Kansai Airport was built on an artificial island that began sinking much faster than expected, teaching engineers a vital lesson about soft seabed settlements. To stabilize the ground, engineers used the sand drain method, installing thousands of pipes to remove water from the mud and compress it into solid soil. In Norway, this technology is being scaled up. By squeezing the water out of the fjord's silt, they create a rock-hard base for the massive anchors. Suction piles, massive steel cylinders that use the weight of the ocean to lock themselves into the floor, provide the primary grip for the tunnel. These cables are kept under constant tension, ensuring the tunnel that stays perfectly level even as the tide rises and falls twice every single day. It is a delicate dance of physics. The buoyancy of the air inside the tunnel provides the lifting force, while the anchors provide the stability. The components of this system are forged to handle millions of tons of force, designed to survive the harshest conditions for over a century. Regular inspections will be carried out by robotic submersibles, checking for any signs of fatigue or corrosion in the dark depths of the fjord. In areas where the water is too deep for anchors, The tunnel will hang from massive floating pontoons, similar to a bridge floating upside down. These pontoons are essentially specialized ships designed to stay stable in rough seas while holding up the weight of the concrete tunnel sections below. They use advanced ballast systems to adjust their buoyancy in real time, compensating for heavy traffic loads or changing water density in the fjord. One of the greatest advantages of a floating tunnel is its seismic resistance. Being suspended in water makes it nearly immune to ground tremors. Construction is a logistical marathon. Each tunnel segment is built in a dry dock, then floated out to the site and sunk into position. The precision required to join these 100-meter-long concrete blocks underwater is measured in centimeters, requiring the world's most accurate GPS and sonar. This modular construction allows the project to move faster, as sections can be manufactured in parallel across different locations before final assembly. The economic impact will be staggering, unlocking billions in trade and creating a unified corridor for the entire Norwegian seafood and energy industry. By moving the traffic underwater, Norway is also preserving the pristine beauty of its fjords, keeping the views free from massive concrete bridges. This environmental consideration is key to the project, ensuring that one of the world's most beautiful landscapes remains untouched for future generations to enjoy. Sustainability is built into the design, with the tunnels powered by renewable energy from Norway's extensive network of hydroelectric and wind power plants. The lessons learned from the seabed stabilization will benefit future projects globally, from floating cities to transoceanic energy cables and deep-sea mining. Innovation is happening at the microscopic level too, with self-healing concrete that uses bacteria to seal tiny cracks before they can ever become leaks. The internal skeleton of the tunnel is designed to withstand not only water pressure, but also the impact of a submarine or a sinking ship. Engineers have thought of every possibility, creating a structure that is arguably safer than a standard road on the surface of the Earth. The lighting system is designed to mimic natural daylight cycles, helping to prevent driver fatigue during the long journeys through the underwater highway system. Travelers will be able to maintain high speeds safely, turning what used to be a fragmented trip into a fast and efficient transit experience. This project isn't just for Norway, it's a vital link in the European transport network, connecting the Arctic regions to the heart of the continent. For the people living along the coast, it means being able to commute to work, visit family, and access services that were previously out of reach. Small communities will flourish, as the barrier of distance is finally removed by the incredible engineering of the $47 billion project. While the surface remains a battleground of wind and water, the world below is silent, steady, and serves as a testament to human ingenuity and will. The project is a reminder that no matter how deep the water or how high the mountains, humanity will always find a way to bridge the gap. As construction continues, the eyes of the world are on Norway, watching as they build the future of infrastructure, one concrete segment at a time. The road to 2035 is long and filled with challenges, but the momentum is unstoppable as the vision of a ferry-free E39 becomes a reality. It is a marvel of the modern age, a submerged giant that will serve millions of people while remaining almost invisible to the world above it. Even the local wildlife will adapt, with the structures providing new habitats for marine life in the deep, sheltered waters of the Norwegian fjords. Every bolt tightened and every meter of concrete poured is a step toward a more connected, efficient, and sustainable future for all of Northern Europe. Driving through the E39 will be an experience unlike any other, a journey through the heart of the ocean that feels like flying through a futuristic city. Emerging from the depths, travelers will be greeted by the same stunning beauty that has always defined Norway, now more accessible than ever before in history. This is more than just a road project. It is the backbone of a modern nation, a symbol of progress and a triumph of science over nature. Technology and nature work in harmony here, using the latest digital tools to manage one of the most complex physical structures ever built by humans. The E39 floating tunnels will stand for centuries, a legacy of the engineers who dared to think differently and the nation that supported their bold vision. Their work will inspire the next generation of builders to tackle even greater challenges, from bridging the gaps between islands to exploring the deep oceans. The technology developed in these fjords will ripple out across the globe, providing solutions for coastal cities facing rising sea levels and growing populations. Norway's fjords remain as beautiful as ever, their silence undisturbed by the massive engineering feat happening just a few meters beneath the surface. As we look to the future, the E39 project stands as a shining example of what is possible when we combine ambition, investment, and engineering excellence. The connection is finally complete, bringing people closer together and opening up new possibilities for growth, community, and adventure across the beautiful North. From the depths of the abyss to the peaks of the mountains, Norway has conquered the impossible, proving that there are no barriers we cannot overcome together. This is the story of the $47 billion dream, a journey into the deep that changed the world of engineering forever and always. The E39 superhighway, a testament to human persistence, precision, and the eternal desire to bridge the gap between our dreams and the reality we build.